This is video 2A for the Year 7 Mathematics course. In this video, we're going to be covering some example questions from square numbers, under the topic of number properties. The 5 questions we will be going through are now displayed on the screen, so I recommend that you attempt these questions before watching the rest of this video. Question 1. Calculate the first 10 square numbers. So we're being asked here to calculate the first 10 square numbers, or in other words, we're being asked to calculate 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, all the way up to 10 squared. And all we need to do here is multiply each of these numbers by themselves. So for example, 1 squared is equal to 1 multiplied by 1, 2 squared is 2 by 2, 3 squared is 3 by 3, 4 squared is 4 by 4, 5 squared is 5 by 5, 6 squared is 6 by 6, 7 squared is 7 by 7, 8 squared is 8 by 8, 9 squared is 9 by 9, and then 10 squared is 10 by 10. And all these simplify to 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. So our first 10 square numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Question 2. Evaluate the square root of 16 and then the square root of 16 multiplied by the square root of 16. Alright, so the first thing that we're being asked to find is the square root of 16. We know that the square root of 16 is equal to 4, since 4 multiplied by 4 is equal to 16. And so what that therefore means is that the square root of 16 multiplied by the square root of 16 is equal to 4 multiplied by 4, which is equal to 16. Question 3. Evaluate the square root of 81 and then evaluate the square root of 81 multiplied by the square root of 81. So, first of all, the square root of 81 we know will be equal to 9, and this is because 9 multiplied by 9 is equal to 81. And so therefore, the square root of 81 multiplied by the square root of 81 is equal to 9 multiplied by 9, which is equal to 81. Question 4. Write all perfect squares between 20 and 200. So, what we're going to do here is we're going to start off by writing the first few perfect squares. So we know that 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16, and then 5 squared is equal to 25. We can only start our answer at 5 squared, purely because we're wanting to write out all the perfect squares between 20 and 200. So all 4 of these answers up here will not be applicable. So now we can just keep on going with this pattern until we reach that upper cap of 200. So the next one will be 6 squared, which is equal to 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is equivalent to 11 by 11, which is 121. 12 squared is 12 by 12, which is 144. 13 squared is 13 by 13, which is 169. 14 squared is 14 by 14, which is equal to 196. And then 15 squared is 15 by 15, which is 225. However, once again, we only want to write all the perfect squares strictly between 20 and 200, so this last answer here will not apply. Similarly, any answer after 15 squared will not apply either. So all the perfect squares that lie between 20 and 200 are these ones here and these ones here. So in other words, 25, 36, 49, 64, 81, 100, 121, 144, 169, and then 196. Question 5. Consider the following pattern. 1 by 3 plus 1 is equal to 4. 2 by 4 plus 1 is equal to 9. 3 by 5 plus 1 is equal to 16. Use this pattern to evaluate 11 by 13 plus 1 without using a calculator. Okay, let's quickly write out this pattern again, just so then we can evaluate it a little bit further. So we've got 1 by 3 plus 1 is equal to 4. Then we've got 2 by 4 plus 1 is equal to 9. And then we have 3 by 5 plus 1 is equal to 16. And we are being asked to evaluate 11 by 13 plus 1. Now, what do we notice about this pattern? Hopefully the first thing that you should notice is that they all have a common trend in that we multiply two numbers together, then we add one, and then we have a certain number on the right hand side. But now let's dig a little bit deeper, because what we should hopefully notice is that all these numbers here on the right hand side of the equations are all perfect squares. In other words, 4 is the same as 2 squared, 9 is the same as 3 squared, and then 16 is the same as 4 squared. So we know that when we have a setup like these three over here, our answers are all going to be perfect squares. But let's see if we can take this a step further. Because what again you should hopefully notice here is that the link between these three multiplications and then the perfect squares is that the perfect square numbers are all directly in the middle of the two multiplication numbers. In other words, with this first one, we're multiplying 1 and 3, and then 2 is the number which is directly in the middle of 1 and 3. With this second one, we've got 2 multiplied by 4, and then 3 is the number directly in between 2 and 4, and then finally, with 3 and 5, 4 is the number directly in between 3 and 5. So what this therefore tells us is that 11 by 13 plus 1 will be equal to a perfect square. Specifically, the number that we're going to be squaring will be the number that is midway between these two numbers here, or in other words, 12. So the answer for this one is going to be 12 squared, which is of course equal to 144.